This is problem number 77, and it contains a circuit with two batteries and three resistors as shown in figure. So you have to find out the current through resistor 2.00. So first of all, you can label the currents in each branch as shown in figure, like I1, I2, and I3, like this. So I1, then this side, this is I3, and this is I2, and you can see the point B is somewhere here. Okay, and there is battery and something else, and the resistors. Okay, so then you can use Kirchhoff's junction rule to the junction on the right hand side. For these junction, you can see that the sum of the currents on two branches containing current I3 and I2 must be equal to I1. So that is I1 equals to I2 plus I3. So this is the equation 1, you can refer. Similarly, the top loop that contains, like which I already indicated with the light blue color. So it's like this branch. So point A is somewhere here, resistance 2, and here is battery 6 volt. Okay, and so further there is 4 ohm resistance. So here is I3, here is I1, this is negative, this is positive terminal of the battery, and this is 4 ohm. So you can see on this loop, and you can use the Kirchhoff's loop rule again. So that's kind of, this is the battery supply 6 volt. Okay, and you can go like this, and so the current through resistance 4 ohm is I3. So 6V, 6 volt minus, this is current through this resistance. This is I3, the current, and this is, so the product will give you the voltage through that resistance. And similarly, you can see the current through this resistance. Okay, so this is current I1, and this is 2 ohm. So it's like the difference from this 6 volt supply has to be equal to 0. Okay, so you can find out another equation I3 like this. Again, you can apply the Kirchhoff's loop rule to the outside loop, that is the loop that contains both, the outermost loop that contains both batteries 6 volt, 9 volt, and the resistance 5 ohm and 2 ohm, like this. So the total supply would be 6 volt plus 9 volt, and so this is 5 ohm resistance and current I2, and in the upper side there is a 2 ohm resistance and current I1. So again, that the difference must be equal to 0, because the supply is total 15 volt, and so the difference has to be equal to 0. Okay, so you can find out another equation like this, and you can refer this as equation 3, and you can solve all the equation. Like you can use equation 2 and 3 in one, like this. I1 equals to I2 plus I3. This is I2, this is I3, and you will get I1, that is current through the resistance 2 ohm. This is I1, and this completes your solution for part A. For the problem on part B, so you have to find out the potential difference between points A and B. So you can see the figure, and I try to expand it like this. In the loop PQRQP, you can see PQR PQRQP, it has to be different. Okay, PQ, oh, you can just ignore this. Okay, and you can just refer this figure. Okay, so that will make you something more easier. So this is point A. I am referring this figure, okay, the more easier. So this is point A, and this is the potential at this end, and the current through this resistor is already calculated, so it's quite easier now. And this is the another battery supply, and this is the potential at end B. So you can see the potential at end B must be equal to this. Okay, so it's like BA means at this end, and it's going like this clockwise direction. That's why it's draining the potential BA. So that's why 2.37 times 2 ohm. So the product of these two will give you the potential, and here this is 6 volt. So you can focus on the direction. So that must be BB, that must be equal to BB. So you can write like this and solve. You will get 1.26 volt. So this is the potential difference between ends A and B of this circuit.